Good evening, my YouTube viewers. In the last video, we were talking about the measure of central tendency. And now, the measure of central tendency. And in this video, we're going to be talking about the measure of dispersion. So the measure of dispersion is a statistical concept that quantifies the spread, variability, or distribution of a data set. It provides insight into how much the values in a data set differ from each other or from a central value, like the mean or the median. And then what we're going to do is we're going to write a program in Python to describe the measure of dispersion. And the way that we're going to write this program in Python is the first thing that we need to do is we need to import the libraries that we're going to use to write the program. So the first library we're going to import is numpy as NP, which is a numeric library that creates numpy arrays, it creates distributions, and it also performs numerical calculations. And we're also going to import statistics, which is an inbuilt module within Python. So the first thing we want to do is we want to get some data. So we're going to have an example data set. So of some numbers. So your example data set is 5, 7, 8, 10, 12, 15, 18, 21, 22, and 25. So these numbers range from 5 to 25. So the first thing we want to do is we want to calculate the range. So your data range equals max data minus min data. So that's going to be 25 minus 5, so that's going to be 20. And then what we're going to do is we're going to calculate the quartiles, quartile 1, quartile 2, and quartile 3. So quartile 1 is 25th percent, quartile 2 is 50th percent, and quartile 3 is 75th percent. So we're going to use the percentile function in Python, in NumPy to do that. So Q1 equals np.percentile brackets data, comma 25. Q2 equals np.percentile brackets data, comma 50. Q3 equals np percentile data, comma 75. So that's your first, second, and third quartiles. So now what we're going to do is we're going to calculate a specific percentile that's not a quartile. So we're going to say percentile 90 equals np.percentile brackets data, comma 90. So that's going to be the 90th percentile of the distribution. So now we're going to calculate variance. Variance equals statistics.variance brackets data. And now we're going to calculate standard deviation. Standard deviation equals statistics.stdev brackets data. And then also another way that you can calculate standard deviation is actually the square root of variance. So if you wanted to do standard deviation equals statistics dot square root dot variance dot data, that would also give you the standard deviation. So we're going to print the results. We're going to print the data set, the range, the first quartile, the second quartile, the third quartile, the 90th percentile, the variance, and the standard deviation. So your range is 20, which is what we calculated manually in the beginning of the program. Your first quartile is 8.5. Your second quartile is 13.5, and it's also your median. Your third quartile is 20.25. Your 90th percentile is 22.3. Your variance is 48.55, and your standard deviation is 6.96. But what I want to do is we'll just say standard deviation 1. I just want to see this. But it's going to be Just want to make sure I've got variance spelled correctly. I just want to try this out because it should be, because the standard deviation is the square root of variance. So it should give you the same values, but I just want to check it out since I'm here. I've got the I just want to try it that way. See if I get. So you can see standard deviation 1 and standard deviation 2 are exactly the same thing. And you can use statistics.stdev to get the standard deviation. But I just wanted to show you a different way to do it so you will know that the standard deviation is actually the square root of variance. So if you can also do it that way if you want to. So that concludes this video. In the next video, I'm going to be talking about measures of association, and I hope that you decide to watch it.